I didn't hear you come in. I'm Tamara Robertson.
When I started this journey, I was just really hoping to make the girls in science proud.
Yep, that's Tamara Robertson. But I'm not just a mythbuster. I'm also a chemical and biomolecular engineer. And this is my shop, where I talk superheroes, technology, and a whole lot of science. Today, we're going to learn about the science of elasticity. But first, that's better. Now, where were we? The science of elasticity. But what is elasticity? And why am I dressed like Mrs. Incredible? Stay tuned to find out in this episode of Superhero Science. Elasticity is the ability of an object or material to resume its normal shape after being stretched or compressed, aka squeezed. Some words associated with elasticity are flexibility, rubberiness, adaptability, and bounciness. As a superhero that shows flexibility is key, you could say that Mrs. Incredible, aka Helen Parr, aka Elastigirl, is a leading expert in elasticity. In fact, superhuman elasticity is her superpower, and it grants her the ability to stretch any part of her body to great proportions, which helps her to stretch long distances while altering her density, allowing her to manipulate her body shape and decrease in volume so that she can still move her mass and have force behind all of her actions. This is important. For instance, in The Incredibles, we see her stretch her limbs to more than twice their normal length so that she can punch a villain while kicking another one. That's pretty cool. She's also able to use her elasticity to shapeshift, changing her form and density into whatever shapes or objects she may want to, such as when we see her morph into a boat to carry Violet across the water, and then again later when she turns into a parachute to save Dash and Violet. She has to save them a lot in the first movie. And then there's the benefit of invulnerability to injury from stretching, even when under several tons of load, like when she carries her entire family in the RV. Though in this scene we see even Elastigirl has her limits. We can see that the stretch is causing her some discomfort. It's written all over her face. Edna Mode actually notes that stretching too far could cause her serious injury, so her suit helps her maintain a safe stretch limit. Mrs. Incredible isn't the only super who has had the benefits of stretch as a superpower. In fact, perhaps the best known superhero with elastic powers is Mr. Fantastic, or Reed Richards, the leader and founding member of the Fantastic Four. They first appeared in comics in 1961 in the Fantastic Four #1. Now, not only is Reed super stretchy, but he's also got STEM powers with knowledge of science, engineering, physics, biology. Hey, that's kind of like me. I guess you could say that we have similar superhero science powers. Getting back to Mrs. Incredible though, why would stretching too far be an issue for someone whose superpower is elasticity? Well, to answer that, we must first understand a type of material known as an elastomer. An elastomer is an elastic polymer. But what does that mean exactly? Well, let's break it into its parts. Earlier, we said that elasticity is the ability of an object or material to resume its normal shape after being stretched or compressed, aka squeezed. Well, a polymer is a substance that is made of long chains of single unit molecules, known as monomers. Mono meaning one, and poly meaning many. For instance, if this rubber band was a molecule known as a monomer, then this chain of rubber bands would be a polymer. And since it's made out of rubber bands, it actually stays pretty elastic. Therefore, if an elastomer is an elastic polymer, it is simply a polymer that is able to be repeatedly stretched to over twice the original length with little or no permanent deformation. Sounds a lot like Mrs. Incredible, doesn't it? Remember her epic punch and kick scene? Did you know that elastomers are all around you? One of the most common forms of elastomer is rubber, which is used for all kinds of things like inner tubes, tight-fitting garments like wetsuits and swimsuits, hoses, rubber flooring, gaskets, rubber gloves, asphalt, and so much more. In fact, One of the most common uses for elastomers is in tires. There are over 20 million tires produced every year, accounting for 56% of all rubber production. Talk about burning rubber. No? An everyday example of an elastomer that can showcase elasticity is the rubber bands I showed you earlier. See, I can stretch this rubber band fairly far, well, somewhat far, and it'll return to its original size and shape without any permanent damage, much like Elastigirl. But if I stretch it too far, it will eventually hit what is known as its elastic limit in my thumb, which is the maximum stress of force per unit area that a solid material can withstand before permanent deformation or breakage will occur. But as we learned earlier, elastomers are a type of polymer, so if we recreate our polymer chain with rubber bands as the monomer units, we could achieve much more stretch, and therefore a higher elastic limit. The elastic limit differs for different materials based on their construction, and being a super, Helen Parr is able to stretch pretty far without any permanent damage. In fact, the Operation Chronos database tells us that she can be stretched up to 300 feet, which is roughly equivalent to the Statue of Liberty's height. Between her superhuman elasticity and her super suit, it looks like those bad guys are going to need to learn to run super fast if they want to escape her grasp. She's like, wow, got it. But there is one other way. What if they knew a bit of science? See, it turns out that while elasticity may seem like an undefeatable superpower, you know, because elastomers are resistant to breaking, tear resistant, and abrasion resistant, there does exist a weakness though, outside of the elastic limit, which we talked about before, one which could actually affect a super flexible superhero like Elastigirl. It's a weakness that we actually see exploited against Mrs. Incredible in The Incredibles 2 by Evelyn, the mastermind behind the Screenslayer. When she's holding Helen captive, take a look.
The temperature around you is well below freezing. Try to stretch and you'll break.
Evelyn's warning to Helen about needing to be careful not to stretch is an all too serious one based in real life science. See, elastomers function due to their rubber-like properties, but as the temperature drops, elastomers begin to contract, becoming harder and less flexible. If temperature continues to drop, elastomers will reach what is known as the glass transition temperature, where the material goes through a full phase shift, causing a permanent loss of the rubber-like properties, and it takes on a brittleness that results in cracks and breaking. In this demonstration by K.E. Stifel of Science On, you see what happens to a rubber racquetball after it is immersed in liquid nitrogen, causing the elastomer to move beyond its glass transition temperature and to its brittle point, so that rather than bouncing when dropped, it shatters. So this is what happens at the extreme limits of temperature. But could everyday cold environments, like say a freezer, have a similar effect? How about we find out? The way that slime works is that the glue is a liquid polymer, and when you add liquid starch, it acts as a cross-linker, causing the strands of the polymer glue to hold together. Now, the Guinness Book of World Records has the world's largest slime record being achieved by 12-year-old Maddie Ray after she created 6 tons of slime, which is about as heavy as an elephant. I bet she'll need a lot of trunk space to get that slime home. Now, there are a ton of variations of slime that are available commercially in shops, as well as lots of fun recipes so that you can get your hands dirty and DIY at home on all of the websites. Slime is the craze that is not stopping, and there's so much fun that you can have with it. Today, if you want to follow along with me, I'm going to be doing the recipe that calls for glue, the liquid starch, and water. I like these ingredients because they're user-friendly, they're not caustic, they clean up really easily. Speaking of cleanup, I added in a little mat here because I know that this is really messy. I also have some paper towels. If you have the ability to have an apron or a lab coat, throw that on as well. I'm going to be super messy today and not have those, but hopefully I can be the messy one and you guys can stay clean at home. Now, you're also going to want a bowl to mix your slime in, a spoon to help, or if you have a spatula, that works as well, a measuring cup, You're gonna want bags for later to divide your slime. You're gonna have the stuff that doesn't get cold and the stuff that does. And then I am going to wear some safety goggles because safety first. But yeah, let's get this started. This is gonna be a lot of fun. So first you're gonna wanna combine a 1/4 cup of water and a 1/4 cup of glue. If you find that your slime is super slippery, then you need more glue. If you find that it's super sticky, then you need more of the liquid starch. Okay, and now what we're gonna do is we're gonna mix this all together. So if you're gonna wanna change the color, add like 3 drops of food coloring, whatever color you choose. If you wanna add glitter, do like a teaspoon of glitter right now. This is when you do it. Okay, so now we're gonna add a 1/4 cup of liquid starch. And so now I'm gonna start mixing this. And this is gonna get like really cross-linked. See, now this is starting to actually have a nice slime texture, but I'm having to squeeze to get to that glue. And then what I do is I roll it around in the liquid starch again because it gets too sticky. So you want all of the liquid starch in this bowl to be in this slime. So what I'm gonna do is I'm actually gonna divide it up right now. And I'm gonna have my bag that's gonna go in the freezer, and I think I'm actually gonna put the other bag in the fridge. Okay, so it's been 30 minutes, so I have my frozen slime and my regular slime. And what I'm gonna do is I'm gonna get on my super sophisticated gravity tester, that stool that has a ruler taped to it, and I'm gonna hold these up and see which one goes quicker. Okay, I have my room temperature slime and my freezer slime. Put my hands at the same height and start to let them fall. You can already see the non-frozen is going much quicker. Oh, it's already to the ground. Whoa, 2 of them dropped before the frozen one got there, and now Dexter, oh! Dexter caught the frozen slime. So, how did your testing go? I can't wait to hear all about it. Share your videos, tag me, share them on your socials. I want to know what you thought was going to happen and what actually happened. Now I'm going to go clean up all my slime and wash Dexter off. Well, that's it for this episode of Superhero Science. I hope that you enjoyed learning all about Elastigirl's superhuman elasticity power and that you were able to observe some cool science with your slime. Until next time, no Dexter, no, that power's next week. Don't worry, he'll eventually get it right. So until next time, remember, superhero powers are only ever a science lesson away.